This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the D'Alembert's principle and its application for connected bodies. The course outcome for today's topic is apply D'Alembert's principle to a dynamic equilibrium system by introducing the inertia force for knowing the acceleration and forces involved in the system. The topic covered would be D'Alembert's principle and its application for connected bodies. The topic learning outcome is application of D'Alembert's principle to engineering problems and know the effect of forces in the movement of the bodies. First, let us understand how the connected bodies are represented. Connected bodies are those bodies which are two or more in a system. Let us say in a system there are two or more bodies and all these bodies are connected using some means. The means of connection may be using a wire or using a string or using a bar. Anyways, the source of connection may be anything, but if two or more bodies are involved in the system which are connected to one another, then this type of system is called as the connected body system. The bodies may be directly connected to one another also. That means two or more bodies are involved in direct contact of both the bodies. So the connected bodies are the bodies which are involving a means to connection for each and every bodies that are involved in the system. So here in this case, the figure which you are seeing, there are two bodies present. One is 200 Newton body and other is 800 Newton body. So these two bodies are being interconnected by using a string here. So this system can be termed as the interconnected system or connected body system. So for this system, how the implementation of accelerations or the inertia forces will be happening, let us consider. As we know, the D'Alembert's principle states that all the dynamic equilibrium condition systems will be happening only because of the inertia force that is involved in the system. That means a system will be in dynamic equilibrium with the inertia force. So that's the reason all the forces resultant and the inertia force, that is minus MA, both combined will be 0. Right? So the resultant will be equated with the inertia force. That's what the D'Alembert's principle states. The D'Alembert's principle statement is given as R minus MA is equal to 0, which relates that the forces that are involved in the system are equated with the inertia force, of the system. So that's the reason this resultant, the resultant and the inertia force, that is MA, will be summated to give the result of 0. Then we can say that the forces are equating to one another and then the system is becoming in dynamic equilibrium state. This is what the D'Alembert's principle states. So as per the D'Alembert's principle, whenever there are bodies involved in the movement, we can say the system will be in dynamic equilibrium with the inertia force. So in this present system which is given, there are two bodies. One is 200 Newton body and 800 Newton body. So for this system, there is a force that is being acted here, which is 400 Newtons, and this force is being acted towards right side. By our common sense, we can say that as the force is acting in the right hand side direction, this system which are connected to one another, the total bodies will be moving in the right hand side direction. This is what we can say. Okay. So for this system, we can involve the inertia force and we can involve the force terms, As this force term is involved and the velocities and accelerations are involved in this system, then we can implement the inertia force term for the system. The representation of the free body diagram for both the bodies is shown here. The first free body diagram is for the 200 Newton object, where there is a string attached here at this point. There is a string attached here at this point, and we can show the value of tension. Whenever there is string attached to any object, there will be tension acting in the string. Okay, so in this string, which is used to connect these two bodies, there will be tension acting. And also remember, the tension will always act away from the object. Tension will always act away from the object. That means when you consider this 200 Newton block, the tension will be acting in the right side direction when you consider this 200 Newton block. And for the same string, if you consider this 800 Newton block, then what happens? The tension that is represented for this 800 Newton block will be acting towards left side. That is away from the object. So whenever you are considering the individual objects, the tension direction should be considered. Thus, for this 200 Newton block, the wire is or the string is tied here, and the tension can be shown in the away from the block direction. So that is given as T. And we can say there is some, if it is a rough inclined or rough surface, then we can say that there will be friction prevailing here. So we can say that the friction direction is given towards left side. Why this is happened? As we have already discussed, the force is being applied here towards right side. So both the objects will be moving towards right side as they are interconnected. Right? This 800 Newton block will move towards right side, and because of that, this 200 Newton block will also move towards right side as these are connected. Okay, so as this 200 Newton block is moving towards right side, we can say that the frictional force at the contact surface will be acting towards left side. And obviously, the normal reaction here would be towards the object, that is N1, given as N1. Now, we need to represent the inertia force here. Why? The velocities and forces are involved here, so we need to represent the inertia force. Now, in which direction the inertia force should be represented? That is the question. So, we have already discussed so many times that the inertia force should be represented opposite to the direction of the acceleration. Right? Now we have considered that object is moving in the right side direction. That means it is achieving the acceleration in right side direction. So we can say the inertia force will be acting opposite to this direction, that is MA. So in this way, we are representing the inertia force towards left side. And we have considered M1A here because M1 is the mass of the object 1, that is 200 newtons weights mass. Okay, if you observe carefully, we have considered the acceleration as A, not A1. Why? Because as this is a connected body system, both the objects or all the objects that are involved in the system will have the same acceleration. It's not like this object will have another acceleration and this object will have some other acceleration. It's not like that. As these two bodies are interconnected, or in that case, any number of objects that are connected to each other, all the objects will be having the same acceleration, depending on the surface on which they are moving, or the way which they are moving. Depending on the way which they are moving, the objects will have the acceleration, same acceleration, right? So this is the free body diagram of the 200 Newton block. Now coming to the free body diagram of 800 Newton block. For this 800 Newton block, we have drawn the block as it is here, and at this connection point or the string connection here, we are showing the tension in left side direction because it is in away from the object direction. And coming to this force which is acting at this point, the same force is shown here at the same position, that is 400 newtons. And the friction, as here the contact surface, the frictions are involved. This object is moving in right side direction, so the friction will be towards the left side direction. So that is given as F2, friction in left side direction. Immediately after friction, we will be implementing the normal reaction, which will be towards the object. And now the 800 Newton weight, which is shown like this. Ultimately, we need to represent the acceleration inertia force direction, right? So this 800 Newton block is moving towards right side direction. That means it is achieving the acceleration in the right side direction. Hence, the inertia force will be having in the left side direction. That would be MA. Okay, so that is the direction in which the inertia force is acting. And inertia force value is M2A, where again acceleration is taken as A here, not A2 or A1 anything else. So this is how the representation of the inertia force happens for the connected bodies. Do remember, as you are seeing in so many cases, the representation of inertia force is happening using the dashed line, okay, dashed line and arrow mark. So always this dashed line and arrow mark represents the inertia force in whatever direction it is acting. The dashed line and arrow mark will be represented for inertia force. Okay, you remember that. Now let us go to the another example where the bodies are connected on the inclined planes. Bodies are connected on the inclined planes. So first let us take the 100 Newton body and let us draw the free body diagram for this. Okay, this is 100 Newton body. So the 100 Newtons is given as vertically downwards. 100 Newton is given as vertically downwards. So as this is an inclined plane problem, what we need to do, this vertical force will be resolved into components. Okay, so that resolution of the components would be normal to the plane and along the plane. Okay, and the components, this is the 60 degrees inclination and the components would be 100 cos 60 perpendicular to the plane and 100 sin 60 normal to the plane, along the plane. So in this way, we will be resolving the components. Coming to the frictional representations. Here, as the connection, as the object is in contact with the rough surface, the frictional representation will be here. Now what we are considering here is, as this is a 100 Newton object that is more weight than the 50 Newton object, we are saying that this 100 Newton object will be moving down the plane in this direction and 50 Newton object will be moving up the plane in this direction. We are considering that as it is 100 Newton plane. It may be, it is just an assumption. It is just an assumption that the object is moving because the inclination of the both the planes are varying. That is different, right? So depending on the inclination and condition of the friction, the movement of the objects will be given. So here, as we can see, the 100 Newton object, it is moving in the downward or down the plane direction. What is happening? That means the acceleration is happening in the down the plane direction. So obviously, the inertia force should be given in the up the plane direction. Also, the tension, here the connection is happening because of the string. Let us say it is connected using a string. Then the tension is shown away from the object. And as this object is moving in the down the plane direction, the frictional force will be acting in the up the plane direction. Right? So in this way, and normal reaction as usual, we will be showing it towards the object. In this way, we need to represent the free body diagram of the connected body, where the inertia term is involved. Okay. Now let us see the free body diagram of the 50 Newton object. As we have discussed, we are assuming that the object is moving in the left side direction for this plane, up the plane we can say. So that represents this acceleration is happening in the up the plane direction. Then the inertia force MA is happening in the down the plane direction, as this is the opposite to the acceleration direction. And remaining things are as usual. The representation of frictional force, as the object is moving in this direction of the plane direction, frictional force will be in the down the plane direction. And this 50 Newton force is the vertical force. Hence, it would be an inclined force for the case that is selected. That is plane. Inclined plane is happening. So, that would be a inclined force for that situation. Then, this 50 Newton will be resolved into components. Along the plane component and normal to the plane component. In this way, we will be showing the free body diagram and also the connection here, the net string which is attached to this object, the object's tension will be shown here. This is how the free body diagram of the given inclined plane condition will be taken. Now let us see another case where the connected bodies are through the pulleys. Okay, free pulley. Pulleys are the equipments which are used to move the objects freely. Easily we can move the objects from lower position to higher position using the pulley. So here there are two objects that are connected with the string over this pulley. Okay, string over this pulley. So for this, how we will consider the free body diagram? For the 300 Newton pulley, what we are doing is this. As this 450 Newton is of higher weight, we are considering that the object is moving in the downward direction here. So 300 Newton is moving upward direction. So as this 300 Newton is accelerated in the upward direction, we are considering the representation of inertia force in the downward direction, and the tension T for this connected string is given in the upward direction, and the weight of the object is shown in the 300 Newton downward direction. Always the weight of the object will be acting in the vertically downward direction. Then for 450 Newton, again what happens? It is accelerating in the downward direction. So the inertia force will be towards upward direction. If you observe carefully, the acceleration we are considering it as the same, because these two objects are being connected using a single string. Okay, and the direct involvement of the movement is present here. Direct involvement of movement is present here. So the inertia force will be given in the upward direction, as this 450 Newton is having an acceleration in downward direction, and the tension in the connected string and weight are shown as shown in the figure. Okay, so this is how the representation of inertia force for the D'Alembert's principle, utilizing D'Alembert's principle, will be given for the connected body motion. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.